Okay, in this video, we're going to look at examples of exponential decay. So we've already previously looked at exponential growth. Now we're going to look at problems that deal with decay. Make sure you put today's date in the top right corner. Okay, so for our example today, let's say that Victor buys a car for $20,000. The car's value depreciates 5% each year. So that word depreciate means that the car's value declines or is decreasing. What will his car be worth in 4 years? So we're going to go back to that equation that we used, the y equals a to the bx. And remember, a is your initial value, b is your rate of growth, or decay, since we're decaying in this problem, and then x is your units of time. So in this problem, our initial value is 20,000. The rate of growth is going to be 0.95, and then time will be 4. So I can actually rewrite this in this form, 20,000 times 0.95, and then we're going to put to the x for right now so I can use it on my calculator. Alright, so let's see what that looks like on a calculator. I'm going to hit y equals, do 20,000 times 0.95 to the x. Hit second table, and so what we're going to see is that these values are decreasing over time. So the value of the car is decreasing over time. So making a table, we have what the car is worth initially at $20,000. So right when you buy it, it's worth $20,000. And then we're just going to fill in those numbers over time. So after 1 year, it's now worth 19,000, then 18,050, 17,148, and then finally 16,290. So let's take a look at that equation again. Here's our equation. The 20,000 makes sense because that's the initial value. The 0.95 might be a little tricky. And what's different this time, because we're decreasing, remember when we did growth we added 1. When we're decreasing, you take your percentage and you divide it by 100 to turn it into a decimal. And now this time, in order to find the rate of change or the growth or decay, you have to subtract it. And you subtract it from 1. So 1 minus 0.05, that's where 0.95 comes from. because we're decreasing from our original value. And to show that, think about what we did yesterday. Start with your initial value, and then multiply it by 1 minus 0.05. 20,000 times 1 is 20,000. 20,000 times 0.05 is 1,000. So when you subtract them, you get 19,000. So that's where that 19,000 came from. So when you're dealing with decay, you subtract from 1, whereas before when we had growth, we added our rate with 1. And so the answer to our original question, what will this car be worth in 4 years? The car is worth $16,290. Alright, let's try another example. A lot of times you'll see growth and decay represented with population. So the population of Illinois is about 13 million people. However, the population is decreasing %3 per year. What will the population of Illinois be in 20 years? Alright, so let's go back to our equation. It's y equals a times b to the x. Remember, a is your initial value, so in this problem, a is 13 million. B is the rate of change, so that's 3%, so that means 3 over 100, which is 0.03. And then I gotta do 1 minus 0.03 because I'm decay, so that's 0.97. So the rate of change here is going to be 0.97. And then remember, x is just your unit of time. So plugging that into this equation, we would get y equals 13 million times 0.97 to the x. So this is going to show the decrease in Illinois' population over time. So if I want to know what the population will be in 20 years, I'd replace the x with 20, and then we just type that into the calculator and see what we get. So in 20 years, if Illinois' population continues to decrease at 3% a year, the population of Illinois would drop to 7,069,326 people. So that's a pretty big drop over that time frame. But that's decay. So the difference with decay is that you're subtracting from 1 when you're dealing with the b value, that rate of growth or decay. Alright, so you should be able to work on practice number 6 now with decay problems.